Hi, everyone. Thank you for joining us today. My name is Madalyn Massey. I'm a 2021 Geo-Launchpad intern with UNAPCO. I currently attend Front Range Community College in Northern Colorado.
Hello, everyone. My name is Patrick Walston, and I'm a recent graduate of the geology program at San Juan College in Farmington, New Mexico. I'm very excited to be a part of the UNAPCO Geo-Launchpad program.
Today, we'll be sharing our project compiling and creating recommended practices for the preservation of geological data to promote the FAIR principles. The FAIR principles being findable, accessible, interoperable, and reusable. To give you an overview of our project, the National Geological and Geophysical Data Preservation Program, or the NGGDPP, which we will refer to as the Data Preservation Program throughout our presentation, manages the USGS Materials Repository, which houses the Core Research Center and National Science Foundation ICE Core facility. The Data Preservation Program promotes the preservation, curation, retrieval, and availability of public data and samples for research. The goal of this project is to continue supporting USGS and the Data Preservation Program. And in doing so, we will be producing 3 updated recommended practices for the topics of structured promotion, also known as SFM, digital scanning, and digitizing well logs. To give you a better understanding of why following recommended practices is helpful, we've created a general workflow of which we followed for producing these 3 practices. Beginning with research, our USGS mentors, Mickey Johnson and Lindsay Powers, provided us literature and sources for developing a better understanding of data collection methods. With this background knowledge, we were able to move into outreach. This is where we were connected with various experts within the science community. I myself was lucky enough to be paired with Shelley Llewellyn, who is an avocational paleontologist, of which we'll be discussing more in our structure for motion practice later on. Our next step in this process was to draft our protocol, our recommended practices using protocols.io. Protocols.io is one of the many science tools available for collaborating, managing, and publishing scientific protocols. After drafting this, our USGS mentors provided feedback and suggestions from which we were able to move forward, revise, and finalize. Our protocols are currently under review, but will be published upon following USGS's internal reviewing and publishing procedures. Moving into tools, during our project, we were provided access to our Microsoft Teams and our team Trello. Microsoft Teams was our main method of communication where we scheduled meetings, had room for guidance and clarification, as well as a place to store our research and sources. Trello is a list-making application where our team could create tasks and track statuses of those various tasks to complete our project efficiently. Moving into our recommended practices, we'll begin with SFM. This is the representation of physical samples as a 3D model produced from a series of overlapping 2D images collected from multiple angles about the sample. Research and application of photogrammetry has created space for various geological creations, ever-evolving software, and platforms where communities of 3D model creators publish their work. On the right of this text, you will see 2 models published by Shelley to a public platform. By creating updated recommended practice for SFM, users are now able to find tips, follow standards, and properly publish high-quality 3D models. This practice more specifically covers capturing fossils, hand samples, and rock cores for the USGS Materials Repository. Moving into our second recommended practice, we have digital scanning. Digital scanning is a widely known process among various contexts of science. Within USGS and the Data Preservation Program, the goal of preserving and curating geological data, this practice provides workflows with the application of the FAIR principles. Again, these principles ensure that data is findable, accessible, interoperable, and reusable. This practice also aids, thank you, Anika. This practice also aids in preventing physical loss of geological materials and by maintaining the research value. So an example of this would be a historical field notebook. By scanning the physical materials with high standards of equipment and software, the materials repository can then collect the field notebook for long-term storage. Patrick will now take over and tell us more about digitizing in the context of well logs. Thank you.
Thank you, Maddie. Well log records are measurements that have been sent from geologic instrument packages inside a well, and they're traditionally printed on paper or film. And currently, many well logs in paper and film format are aging and at risk of damage or destruction during the storage and access part of their life. And updated workflows that include preservation techniques and modern technology ensure the efficient digitization of sometimes fragile records. Workflows for digitizing well logs may differ from one geologic repository to the next, but standard protocols suggested by the USGS provide a greater depth of information and resources with consideration of data preservation, availability, and interoperation. I researched the history and current practices for scanning log data from physical records to digital images in order to provide the updated resource documents and web pages. I also created methods to help direct records management teams toward the goal of increased public access through the use of digital identifiers and metadata. A bit of discussion about these recommended practices. The documents are considered to be living alongside working collections, which means that they'll be updated every so often to account for new practices and changes in technology. The practices promote the consistent use of scientific standards for preserving, publishing, and accessing geological and geophysical data. Digital identifiers, also called persistent identifiers, should be created and posted to a central database like the USGS National Digital Catalog in order to promote researchability and reuse. By using recommended practices and persistent identifiers to host as much metadata information as possible in one central location, scientists will have easier access to research information that shares a common standard and can be reused without accounting for any variance in data integrity. As far as challenges, it's interesting that scientific working collections contain large varieties of samples, which may require individual preservation or record-keeping techniques. Our three practices only cover a small area in the use of collections information. Another challenge facing the data preservation program are repository local digital archives, which may not have been designed with consideration of metadata interoperability. The metadata ensures that the public data is findable, accessible, interoperable, and reusable. So moving forward, these recommended practice documents will be posted on the USGS website as resource materials for SFM, digital scanning, and digitizing well log information. And they'll also be continuously updated as living documents to provide current solutions for technological problems, as well as direction to selected resources, such as the National Digital Records Catalog. Maddie and I will also help conduct and be participating in a series of 3 webinars this fall, which will focus on the updated strategies we developed for document preservation and data interoperability. During our time with UNAVCO in Boulder, Maddie and I had the opportunity to meet our USGS mentors, Lindsay and Mickey, in person and tour the Geologic Materials Repository and Ice Core Research Center at the Federal Center in Lakewood, Colorado. Lindsay and Mickey developed our understanding of the project's importance by illustrating that although the Ice Core Center is a special form of geologic materials repository, it too can benefit from specialized, updated, recommended practice techniques like the processes we worked on. That's all for our poster, and I'd like to thank our project mentors with the USGS, Lindsay Powers and Mickey Johnson, for sharing their time and insight. We'd also like to thank Kelsey Russo-Nixon, Anika Knight, UNAVCO, and the National Science Foundation for providing this academic and professional development opportunity. Thank you to Shelley Llewellyn for her time and guidance, and Deb Stewart and the Records Management Department at the Kansas Geological Survey. Also, thank you to GSA and the On to the Future program for helping to fund our travel to GSA Connects 21. And we would also like to acknowledge that some research was conducted on the traditional territory of the Cheyenne, Ute, and Sioux Native American tribes. Thank you, and we'll take any questions now.
Great job. Okay, so we'll open the floor for questions. If you have any questions, you can either type them into the chat or you can raise your hand and unmute yourself. Go ahead, Patrick.
Patrick, you mentioned that you were doing some webinars, you said, in the fall for this.
Yeah.
Who is your target audience for those webinars?
The target audience would be people who work with data input and like digitization or public accessibility of of records information. So mainly, well, there are many focuses, and we're going to be collaborating with the USGS, covering a wide range of topics. And our part in these presentations will be these practices that we've developed, mainly public access and interoperability.
Okay, great job on this, to both you
Thank
and
you.
Maddie.
Thank you. What was the most interesting or surprising thing you learned? For myself, from the project, probably doing the project, working from in person, going to hybrid was really interesting. The transition, I guess I thought I knew what I expected, but then it was a little bit different. Daily work, including all the meetings and meeting deliverables. It's different, the environment that you're in, that you start in and then change to. So the shift was interesting. I guess I just wasn't expecting that.
For me, the most interesting thing was learning about the material or the geologic repositories in various state surveys, and the problems that they encounter can be really like unique and interesting, whether it's hardware difficulties or challenges in the storage process. It's generally pretty interesting when they have problems.
Shelley, you can ask your question, and we'll shift to the one in the chat.
Okay, hi everyone. Wonderful presentations for everyone. This is such an important area. I had a specific question about the structure for motion component and wondering like what kind of challenges maybe the state surveys talked about with like just holding all that data, or if people like put them into another repository that is more of a public or commercial area. You know, have they come up with a process for moving it over? Because I know there's some like 3D scanning sites that will hold your information, but of course they want money for it.
I couldn't tell, like I couldn't directly answer as far as the process of housing the physical samples. The practice and the work I mostly focused on was just creating like a workflow or like standards that current photogrammetry experts are using. There isn't a public source that is well known for following like tips and standards. So that was the goal of mine. And because it was a hybrid program, the time that we spent in person to see like the processes that you were discussing about was very limited. The only chance that we had to like go see the core research center was to tour the facility. Otherwise, my work was mostly just about collecting like tips and standards used by other photogrammetry experts. So kind of just sourcing everything into one place for that. I don't know the answer directly to the process of issues between repositories and housing the physical samples that are later on used for structure for motion.
Yeah, thank you.
Okay, I hope that helps get a better understanding.
I can add on to that.
Sure.
So the importance of metadata and digital identifiers is that we can host a small amount of information in one central location that will direct you to repositories that are actually housing the files and physical records that you're looking for. And so these repositories have digital archives already built that include websites. So one central location will kind of direct you to the website that you need to be on, and you can get in touch with the facility that is housing the records and files.
Great. Both your answers are great because the process and metadata, I come from a metadata world. It's like, it's so key. So yeah, thank you.
Okay, and Lindsay Powers has a question in the chat. She says, did your experience in this project change your perspectives about opportunities in the geosciences?
I would say absolutely. Definitely, this is my first dip in the pond with geosciences specifically this summer. So it was really exciting just to meet all like the diverse people and geologists that are involved in geoscience. With this project specifically, and even touring the facility, understanding how important it is to have like a basis of supporting sciences. as Geo-Launchpad intern, our project was mostly methodology, not research-based. And so as much as like field work and collecting data in a field is exciting and new, I think that supporting science, I have like a new value and understanding for it, like huge respect developed for everyone involved in situations like even creating recommended practices or updating. A lot of people, I feel like there's not a huge light shined on it, I guess is what I'm trying to say.
My favorite part of the whole internship program was the weekly career circles, where we talk to professionals and learn about where they're at in their career and the kind of path that led them there. And so my understanding of the different subsets of earth sciences was greatly enhanced. And it's awesome to have a better understanding of all the different fields and which direction I could go. But as far as this specific project, it was really interesting to learn about the support that goes on behind the scenes to make it all possible.